In just 12 minutes, let's use Alchemy's new AA Signers package to leverage Particle's Wallet as a service with an account kit. In short, Account Kit is basically an all-in-one stack of different SDKs and packages made for building applications with ERC 437 account abstraction, handling everything from smart accounts with implementations like Alchemy's Lite account to signer integrations like what we're going to be going over today, as well as sponsoring gas, bundling transactions, and so on. And to extend Account Kit, Alchemy recently released AA Signers. AA Signers enables native utilization of different signers, such as Particle's Wallet as a service, to assign a smart account to an EOA generated by that provider, thus plugging them directly into the Account Kit stack. Basically, this makes working with Particle on Account Kit significantly easier because of the direct integration, which takes us to the video today. In just 12 minutes, we're going to go through the process of building a sample application, very similar to the one that we built in the previous Account Kit video, although this time we'll be leveraging AA Signers to implement Particle. So let's jump right into it. So to add a little bit of context, today we're going to be building an application in around 150 lines of code. The goal of this application will be to sign in a user with their social account. In this case, we'll be doing either Google or Twitter, then assign a Lite account implementation to the EOA generated by the social login mechanism, and then we'll use that smart account to send a gasless transaction. So to get started here, let's go ahead and import a few different required libraries. The first will be React alongside useState. We can also import Alchemy provider from @alchemy-aa-alchemy. Additionally, like I mentioned, we want to use a Lite account in this case, so we can throw in Lite smart contract account from @alchemy/aa-accounts. We can also go ahead and import Polygon Mumbai from VM/chains along with ethers, and of course Particle signer from @alchemy-aa-signers/particle. And finally, we can go ahead and throw in notification from anti. Then of course we'll need to close it off here with our CSS. So with all of these libraries imported, we can go ahead and begin by creating our main app component in which we'll throw in all of our main functions. We'll need to start by setting 4 different states. The first will be provider state, along with set provider state as use state. We'll also need account address and set account address, along with owner address and set owner address. And then finally, we'll need user info and set user info. And then additionally, before we create our first function, we can create a quick constant here called entry point address and throw this address in here. This is the standard entry point address for ERC 437. You'll need it within this code. If you don't have it and you'd like to retrieve it, then of course I'll have the repository for this code linked below. Okay, so now that we have all those set, let's go ahead and create our first function. This will be called initialize particle signer, and it'll take one parameter called preferred auth type. The goal of this function will be to first, of course, create a particle signer object, and then call the authenticate method on that object to log in a user with their social account. So first, of course, let's initialize the particle signer object. This will just simply be called particle signer, and that'll be new particle signer. Now, before we continue in here, this constructor requires 3 key values: your project ID, client key, and app ID. To retrieve these, we'll first need to head over to the Particle dashboard and create a new project. All right, so I'm now here on the Particle dashboard, dashboard.particle.network. I'll go ahead and click on add new project and name this account kit demo. Then I'll go ahead and click save. Now within here, as you can see, we have a lot within our dashboard. From customizing the modal UI to configuring our native paymaster and so on. There's a lot of options here, but in this case, we want to stick to the applications menu. We have our project ID and our client key, but we still need the app ID. To retrieve that, let's go ahead and create a web app. And again, name this account kit demo, and then you'll need to throw the domain in which you're hosting this application right here. Although if you haven't gotten to the point where you've deployed it yet and you're still running it on localhost, then feel free to throw any filler domain here and it'll still work. We can go and click on OK, and there we go. Let's now copy the project ID, the client key, and the app ID. I'll now go ahead and throw those into environment variables within my application and continue. You can of course start by setting the project ID as React app project ID. The next we can do the client key along with the app ID. Then additionally within this object, we need to define the chain that we'll be using within Particle Auth. In this case, like you might have noticed earlier, we're going to be using Polygon Mumbai. So we can start by setting the chain name to Polygon and the chain ID to 80001. And perfect. Particle signer is now initialized. We can now move on to authenticating the signer and of course initiating social login. We can do this through await particle signer.authenticate. Then within here, we can start by filling out login options as preferred auth type. This will basically dictate what type of social account we ask the user to sign in with. So whether it's their Google account, Twitter account, email, etc. Then additionally, we can set login to async, login options, and then open up a quick function right here that we'll call await particle signer.inner.auth.login. Then we can pass in login options. So now that we've initiated particle signer and called the authenticate method, therefore logging a user in, we can just simply go ahead and return the particle signer object with return particle signer. Now, in addition to initialize particle signer, we'll also need to create a function called initialize provider. This will also take one parameter called particle signer, which in this case will just be an instance of the particle signer object that we previously initialized within initialize particle signer. Now within here, we'll need to create an Alchemy provider object. Essentially, this object will be sort of our master object for interacting with AccountKit. This is how we'll send user operations, retrieve the smart account address, and so on. To initialize a provider, we can just simply do return new Alchemy provider. And then of course, within Alchemy provider, we can start with API key. Now to define API key, we'll first need to head over to the Alchemy dashboard and create a project over there as well. So now that we're on the Alchemy dashboard, let's head over to the apps menu and then create a new app. I'll name this demo video. And of course, this will be Polygon and Polygon Mumbai. Then I'll click on create app. Now I can head into API key and copy the API key here. I'll now throw that into an environment variable and then continue. So in my case, that's process.env.alchemy API key. Then of course the chain will be Polygon Mumbai. We can also throw in the entry point address that we defined earlier. And then that's all for the initial constructor. But additionally, we'll need to call .connect and pass an RPC client as new light smart contract account, because of course we're going to be doing a light account in this case, which is Alchemy's own smart account implementation. And then within here, we'll need to again pass in the entry point address along with the chain as RPC client.chain, then the owner as particle sign. We can also set the factory address as this value right here. Then finally, we can throw in RPC client. And there we go. At this point, we've initialized Particle Signer, which is our signer object for Particle's Wallet as a service, as well as an instance of Alchemy Provider, which we'll be using to actually do things like send user operations and whatnot. So now we just have 3 more functions to go ahead and write. The first of those 3 will be handle login, which will take preferred auth type. Now a handle login is basically going to take the functions that we just wrote within initialize Particle Signer and initialize provider, and sort of wrap all these up into one function in which we can initialize those objects and set the states accordingly. So to start, we can define particle signer as just simply await initialize particle signer, passing in preferred auth type. Then we'll need to set the user info state through await particle signer.get auth details. Similarly for provider, we can create a provider variable and do await initialize provider, passing in particle signer. Then we can go ahead and set the provider state with set provider state and pass in provider. Now I want to quickly throw in a condition here that checks if provider.account.owner is a truthy value. So if it's defined, then we want to go ahead and set the owner address as await provider.account.owner.get address. This will be the address of the EOA generated by MPC TSS through the social login function. We can also set the account address. This is the address of the smart account with await provider.get address. And then additionally within the front end, we want to display the user's balance in Matic upon request. So in this case, we want to have a button that says something like retrieve balance. And then upon clicking, we go ahead and retrieve their balance in Matic and display it for them on screen. So we can do this within a function called getBalance. Now this will be quite simple. Basically, we just need to make a getBalance request to the Alchemy provider object. Let's do that in a variable called balance. And then we can call await provider state.request, and then throw in the method as eth_getBalance, and then the parameters as account address. So the address of the smart account. This will just make a simple getBalance call to the RPC attached to the provider, and then return that number to the balance variable. And like I mentioned, we just want to display this on screen upon request. So we can just call a notification.success and set the message to balance check successful, and then set the description to ethers.utils.format ether, and then pass in balance. So this will be mapped to a button, and then upon clicking it, we make an eth get balance request, which then displays a pop-up with their balance in Matic. Okay, so let's move on to creating our final function. This will be execute user operation. Essentially what we want to do here is send a sample transaction. In this case, that sample transaction will be a burn of 0.001 Matic. Now doing so within Alchemy's account kit is pretty easy. It's basically just gonna be one function called sendTransaction, which we'll call in a moment. Although we want to sponsor this transaction. So to do that, we'll first need to call provider state Alchemy gas manager. Now within here, we need to define a policy. But first, to retrieve that, let's quickly head back to the Alchemy dashboard and explore their gas manager. So I'm back here on the dashboard. I'm in the account abstraction section under gas manager, and I want to go ahead and create a new policy. I can just call this something simple like test policy, and that'll be for my demo video application. We can go and click next, and then I don't want limits, so I'll go ahead and tick both these boxes and click next. We can also go ahead and skip over this, and then we can go and click on review policy. Finally, we can go and click activate, then grab the policy ID right here and throw it into our application. So now I can set the policy ID to process.env alchemy policy ID. Then I can also throw in the entry point as entry point address. So now that we have that set up, let's move on to sending the user operation itself. We can do this within a variable called txhash, and we can very simply just call await provider state.sendTransaction, and then we can pass in our transaction details right here, which in my case will just start with 2 as this address right here. This is the dead address or the burn address that I'll be sending my Matic to. Then of course I can also throw in the value parameter and pass in ethers.utils.parse ether and then throw in 0.001. And that's it. Once that's executed, the transaction will pop up for confirmation and then be sent to the network. To indicate that it's been successful, I want to go ahead and throw another notification.success, this time setting the message to user operation success. We can throw in the description as transaction hash and then throw in the tx hash variable right here. And that's it. At this point, we've initialized Particle Signer, we've initialized Alchemy Provider, we've handled the social login, of course, which in this case is just calling the functions that we made before. We've retrieved the balance of the account, and we've sent a sample user operation. Now all we need to do is open up a return statement and format all these functions within our JSX. Although within most of these videos, I skip the JSX because writing it live can be a little bit repetitive. So I'll go ahead and get this written and then come back. All right. So as you can see, the JSX is pretty simple. We're just starting by checking the status of provider state. If it's truthy or if it's defined, then we display the user's information, in this case, their name, their smart account address, as well as their EOA or their owner address. Then we also display the check balance button, which is mapped to check balance, and the execute user operation button, which is of course mapped to execute user operation. Now, if provider state is not initialized, so if login hasn't occurred yet, then we display the login buttons, either sign in with Google or sign in with X or Twitter. And that's it. Let's now close this off by throwing in export default and then app. And looks like I quickly missed two things here. This should be AA accounts and AA signers. So now with all that set, let's go ahead and run the application and see if it works. We of course have our two buttons here, either sign in with Google or sign in with Twitter or X. Let's go ahead and give this a try by signing in with X. Go ahead and click on authorize app, and here we are. We have my name, in this case my Twitter name, my account address, as well as the owner address. Let's go ahead and check our balance. As you can see, I have 0.398 Matic. And of course, let's go ahead and try executing a user operation with this button right here. We have the confirmation pop up. I'll go ahead and click on confirm. And there we go. User operation success. And we have the transaction hash right here. So let me go ahead and copy this, then check it out on the Explorer. And as you can see, it was successful. And I transferred 0.001 Matic from my smart account address to this dead address right here. As you just saw, it's easier than ever to use Particle within Alchemy's account kit. Natively within the SDK, you can initialize an instance of Particle Auth and use it directly as a signer. This opens up a lot of really cool use cases that weren't as practical before with the non-native integration that we covered in the previous video. So we're super excited to see how developers use Account Kit, specifically with Particle's Wallet as a Service, to enable really powerful user experience. If you'd like to learn a little bit more about Particle Network and our tech stack, then I'll have a full blog post about our Smart Wallet as a Service, our Intent Fusion protocol, our confidential ZK stack, and so on, linked below. Additionally, if you'd like to try our main web demo or the demo that we made today, then you can also find both of those linked below.